Welcome to Control 4 Driver Development Essentials. My name is Peter Casenza. In this video, we'll take a look at the proxy component of a Control 4 device driver. We'll examine the way that the proxy driver provides defined command and notification interfaces for a device, and also look at how the proxy code interacts with the protocol layer. Additionally, we will discuss how the proxy delivers a common user interface that can be displayed on a wide range of Navigator devices. Finally, we'll look at some other means of interoperability that the proxy provides in Composer Pro. Throughout this video, we will examine driver schema and discuss concepts detailed in the 301 level video series. In order to gain the most from this training module, we strongly recommend viewing those videos prior to this one. Earlier in our training, we defined a proxy as containing the definition for a specific class of device. We know that proxies are comprised of the most common examples of functionality for each device class, and that the use of a proxy provides a common interface between the Control 4 Navigator UI and the device driver. Also, it is important to note that proxies are predefined and supplied by Control 4. In this video, we are examining a proxy driver and will be showing you how proxy functionality is implemented in the device driver. When the device driver is added to a Control 4 automation system, device control includes the predefined functionality that is provided in the proxy. The proxy driver also handles updates based on the user interaction experience through its Control 4 Navigator interface. Throughout this video, we will use a receiver driver for our examples. More specifically, we will be using the Anthem MXR700 serially controlled receiver driver. To start, let's take a brief look at the receiver proxy command list found in the Proxy Protocol Guide. Here, we can see all of the proxy commands that define the command interface for the Control 4 receiver proxy. These commands are provided for all receiver protocol drivers to use. These commands are also recognized by Director. For example, here is the on proxy command. Obviously, it is used in transitioning a receiver to an on state. That's fairly straightforward, but what if our Anthem receiver's protocol doesn't support the use of an on command? Say, for example, it uses a power on command. Director has no idea what power on means. It only knows on. If it received a power on command directly from our Anthem receiver, it would have no way of handling it. That's why our receiver proxy exists. The proxy driver communicates with the device protocol and speaks to Director in a language that it understands. To accomplish this, a proxy command is sent to the protocol using a Control 4 API called Receives from Proxy. Information regarding the Received from Proxy API resides in the proxy interface area of the API reference guide. If we look at some driver code from our receiver driver, we can see where we've defined the Received from Proxy command. We can see that it requires several parameters, including a binding ID value, the actual command being sent in string format, and a table of all included command parameters. Now, let's take a look at a simple command that can be passed using Received from Proxy. Here is the on command. When a user selects a device from a touchscreen, remote, or mobile device, the on command is passed on to the proxy layer or proxy driver. Assuming that the command is a defined Control 4 proxy command and properly formatted, the proxy hands the command off to the protocol using Received from Proxy. At this point, it is important for us to keep in mind that this video focuses on the proxy driver. We'll devote an entire video on the protocol driver in our next video. But for now, it's important to understand that the protocol driver can handle the Control-4 defined on command, and if needed, associate it with a device-specific command that represents powering on the device. Let's take a minute to evaluate what we've done so far in our example of turning a receiver on. We have user-initiated action turning our receiver on. It could have come from a number of user interfaces. Regardless of its origin, our proxy driver receives the message from its own UI to turn the receiver on. Being the receiver proxy, it has a defined on command, and it sends that to the protocol using the API called received from proxy. Our protocol receives the on command from the proxy through receive from proxy, performs any required parsing, and handles the command now that it knows that it needs to turn the receiver on. It does this by sending its own on command to the device using a send to serial command or a send to network command, depending on how our receiver is controlled. Once the command is executed, the protocol may also send an on notification back to the proxy. This notification is sent using an API called send to proxy. This notification aspect is important as it will inform the proxy that the device is on and the UI needs to be updated to reflect a power on state. The example that we have just outlined is an overview of the primary role of the proxy driver. Receive information from a user interface that it recognizes in a form of a defined command. Provide that information to the device protocol driver so that it can parse, interpret, and execute the command. Receive notifications from the device protocol driver in a format that it recognizes, so it can then update its user interfaces. The proxy driver also has other interoperability elements that are worth discussing. When you add a driver to a project in Composer Pro, it loads a default list of device-specific events, variables, and actions that can be used for programming purposes. To demonstrate this, let's create a very simple receiver driver in Driver Editor. We're going to create this receiver with only one other proxy, a tuner. Let's save our test driver and load it into Composer Pro. If we expand our driver while under Programming, we can see that several variables were created automatically: power state, PSN, and radio text. Each of these variables also has their own unique actions that can be executed in programming. When creating a driver, it is useful to review the Composer Pro components provided through a Control-4 proxy. This can prevent you from duplicating work, as well as provide you with ideas on adding additional variables and actions to enhance device control. The proxy driver component of a C4I device driver file represents a critical piece in the driver development puzzle. It provides a communication layer between devices and director. It can communicate with protocols and change user interfaces based on physical device changes. It is a powerful architectural layer that warrants understanding. Hopefully, this video provided you with a better understanding of how a proxy driver works. Now, let's move on to our next video, a look at the protocol driver.